Hello and welcome to another video. This is continuing on from day 9 of Advent of Code, and the third video on this now. But yeah, we're pretty close to done. I've just been for a bushwalk and found a twig on my hair, but that's all good. So what I want to do, I think here, I saw in some other stuff, I might be able to do just something like this, and yeah, so we can't do that. In fact, let's do that. Control Z is hard of my current keyboard mapping. So at the moment we need to do a diagonal, which kind of means that we need to apply this kind of function twice, once with the left or right and once with the up or down. So I think what I want to do is kind of have a function to move just a point, and we can have a non-p, and that can be a point, and there can be direction, and yeah, and I think this will just return a new point. Because that's kind of how we have it for this, and I might not make that a non, and this thing here is kind of what we want to do, that whole thing, and here we kind of want to return that thing there. In fact, we probably could do like a slightly different thing. I'm just going to open the door actually, because it's banging in the wind. This is kind of what we want. So this will kind of take a direction, and well, I guess the door will be closed, so it might just bang in the distance, but that's just how it is. Right, so I think this is good, and here we can probably just have move point, and we can P can be head, and can just be that, and then this whole thing can go away, and this can be point, and here the point will be tail, and the dir will just be the same dir, and that can go away. So that looks like a lot nicer to read there. And if we kind of go to it, we should just have, yeah, that same error, that's fine, because that's basically saying we don't know what this new tail here is. So if we are diagonal, what we need to do is kind of do two operations. We need to go either up or down, and then either left or right, depending on whether the x is less or depending on whether the x is less, we want to go left or right, and then depending on whether y is less, we want to go up or down, and we want to do both of those at this point because we've decided that it's not already touching, and it's not like in the same row or column two away from each other. So at this point here, we if tail.x is less than new head.x, that means we want to move it to the right. So move right. Otherwise, we will want to move left. And then we we also want to go tail.y is less than new head.y, and if that's the case, we want to move down. Otherwise, we want to move up, and that is that. Now, for this, because we're doing like two operations on that, I think that I want this. Come on, there we go. I want this to be a new tail, and it can just be like a point, and x can be tail.x, and y can be tail.y. So we're going to be kind of operating on this. So if we're going to move to the right, we can have new tail equals and move point, and the point is going to be new tail, and the direction is going to be direction right, like that. And if we get that, we can do the same thing here, except we go left. And that means down here we can kind of do the same, except with up and down. So I might just do that and to there, and do that. And so if we are less than, we want to go down, and this we want to go up. And at that point, new tail should be right. And so I think we didn't have an assert, but what I will do is if new, if not new head dot is touching, I think I called it, and new tail, we can just abort there, because that shouldn't happen. So if we run this, it looks like we are compiling, so that's a good thing. And see what output it gives. Oh, it's pretty close. Gave us 12, not 13. Just double check what we were meant to be. Yeah, it was 13. So I guess we never actually add the first point. So here we can go visited, and we can call it tail.2i64 equals true. And I think now we should get the part, well, we shouldn't see a diff for the part one, we should just see that output. All these, which we can probably just get rid of that. It still had the same answer actually. Is that because I didn't save it? I pushed some keys I didn't want. Yeah, so save it, do it again. What do we get? No, we still get that. So that didn't actually change anything. And we do it after each time we move the rope. So I think what I need to do is at each step, yeah, I think at each step we kind of need to say what it is. So maybe at, no, we do that. I will do it here. So yeah, the first one we know what it is, but here we can go. So equals that, and new head equals that, and tail equals that, and we can add head and tail. do something like that, and then that should give us a bit more output. We can kind of confirm with this, I guess. See what is happening. Hopefully that door is not too annoying, but it is what it is. So this is like maybe a bit long, so what I think I might do is do that. Just so I can have this window as well as this window, we can probably also put that there, and maybe we can do something like that. And right, so I did that error code 1, but if we run it again, it will be fine. Right, so we're going right, and so at this point x goes to 1 for the head, and the tail stays at 0. That sounds good. This next one doesn't look right. X goes to 2, but for some reason x goes to 1, then y goes to -1. That doesn't seem right. So at this point, yeah, so what is happening? So we should have a case where new head will be this 2, 0, and the tail will be 0, 0. So that should be kind of matching. I see what I've done. Yeah, I've just done one case. I've done if it's on the same row but not the same. So I think I want to actually do it in a different place, because they kind of say the rules in a different way. Right, so if new head dot head is to away. It's not the best thing to call it, but that is just what I'll call it. And we will copy that thing. That didn't copy, I don't think. That copied. Right, so if we do that, then do that, and we will put that as a function on the struct. Function is to away, and we will take this, not a thug, and we will also take a anonymous point, and we'll just return a bool, and we will return this, I guess, except we won't return just that. We will return this, or the same thing again, and that bracket, except with the x's replaced with y's, and vice versa, not g's though, y's on that one, and these y's replaced for x's. And we probably want to not call it new head. We probably just want to call it P, and this can be this, and this can be this, and this can be P, this, and that can be P. Yeah, that looks a lot nicer. This, and that can be P. Right, and I think that looks good, so we can close off that function there, and there should be one right there. Cool, so I think this should not compile for some reason. right, because I did a this.g, that should be a y. Right, now that's compiling. Not sure why we got, oh, that e is from there, so it's like just repeating the last line. I'm not too sure where. Right, so this diff output didn't have the, so if we scroll up, it had the part 1 being different from the expected. So that tells me that this is now just working, and we can probably take away this debug stuff, and then we'll have that, and I'll also scroll down to the answer, because we'll most likely be able to just get the answer once we wait for it to compile. Right, so it passes the example, and if we run it on this, then we should get the answer for this, 5858, and we can submit that, and that should be part 1 done. 1 gold star. Right, then outputs, day9.output, and put that there, and have a look at this thing. We do a bunch of stuff. Oh, we did like some stuff in New Day. Yeah, I'm happy with that. Day 9 part 1. Right, so we'll commit that, and now we are ready for part 2. So that is good. Right, so our part 2 rope snaps, cool. I love how like this rope is real dangerous, even though it's like real tiny and yeah, I don't know. Gotta make a problem there. Right, so kind of grab them. Right, so now we have to have longer ropes. This could be a bit trickier. Right, so we have, we were having a knot here at each end. I don't actually recall reading that, but yeah, so a knot at the head and the tail, but now we have 10 knots, I guess, all throughout. And like each one will kind of follow each one. Gosh, yeah, that makes it a bit different, I gotta say. So my theory before of what the next answer wasn't quite right, and we're getting bigger examples, so that's kind of good. Right, so we still just need to keep track of the last tail, so number 9. Yeah, we could potentially like just apply that operation 10 times. Well, like have the move the head and the, because this function that we call move rope, it kind of just takes the head and the tail, and we'll probably have to amend the move rope, because the first thing we do is get the new head, and what we could do is change it so instead of passing in the old head, we pass in the new head in a way, and we just return the new tail because we know where the new head is. Yeah, and then we just have to do that 10 times to get all the things. So I think mute rope, it can be yeah, I wonder if we can do something like might have a look at the source of jakt and look at some samples for arrays, and I kind of want a, I think this L value, I kind of want a array of a certain size all populated with the same value, which I can get around. It's like only 10. So what I'll do is have this, so our rope is going to be an array of points, and then for I in 0.10 we're just going to push a new point of x 0 and y 0 and do that. Now at this point we will want to p in, actually no, I'll do j in one dot rope dot length, and for each one we will want to, and we make that really cool. So we want to have rope of j minus 1. Well, first off we want rope of 0 to just become move rope of rope 0 and whatever direction we are doing it in, and we need to do p, so this will be p that, yeah. And then at each step we want this to be, yeah, that was actually just move point. So we move the first point and then we want to move the rope. New head can be rope j minus 1, and tail can be rope j, and the direction, I guess the direction will always be the same, but no, the direction is just kind of whatever direction was. Yeah, we kind of just want to move it towards, so if it's right, then that, and if it's 2 away, we want to move it to the right direction. Yes. So this direction might not be quite right. To do the may need to change on each tool. That could also be worked out, similar to how we work out the diagonal stuff. Yeah, so like if it's already touching, we don't need to do anything. So new head can be there, and we'll take away that, and we will just return a single point. Yeah, so this work. Yeah, I think this just needs to do work out what the and then this is all good. Then we will just need to do that and do So that means that will do the rope, and yeah, I think we just don't want to pass a dirt with it. And so I guess the old one, so I'll try and make part 1 and part 2 kind of work the same. I suppose I can just have, because this is wasn't what I thought, we'll just have a set, and that was a that brace, I believe, and visitor dot add, we'll call it add, I guess. And yeah, we will also just have 2 of these, and one will track the second element in this rope, and one will track the 9th element, the master, well, the 10th element actually. So visited, did I do 1 and 2 or just 1? Dot add. Now, the example sets, how do we do it? We go add, and I think I want to go back there, add, and this is going to be tail, not tail, it's going to be rope 1.2i64, and we're also going to do visited 2.add rope 9.2i64, and then we just don't really need that, and we can do a part 2, that's the one, and part 2 can be visited 2. So this is kind of doing it. We don't need that to do because we've already decided that that to do is that. So here, the move rope, we won't take a direction. We will just work it out. Because here we work it out. So at this point, the column should be kind of the same. Either the column or the row should be the same. So if the x's are the same, then it will be in the same column. So this will be return move point, p will be tail, and dir will be a match on, yeah, I'm not sure we can do matches like that. Now we need to go if new head dot y is less than tail dot y, that means the tail needs to move up. So we would return move point p, it can be tail, and dir can be direction up. Otherwise, we would. That's not what I wanted to do. I wanted to do that, and otherwise, I want to do direction down. Right, and if the column isn't the same, then the row would be the same. So then I kind of just want to do the same things except x and y, round the other way really. So this would be x, and this would be if the new head is less than x, then we want to move to the left. yeah, left. And otherwise we want to move to the right. And if that is all that, we should have theoretically done that. It's like a bit gross, but that's all that, and we do all the direction for that. So I think like maybe we'll go Vim outputs day 9.example and keep track of the 9. So part 2 should just be 1. And this other example does like some more crazy stuff. Oh yeah, it makes like a sweet thing, and there'll be 36. So what we can do is just double check that the terminal is like a bit interesting. To reset, kind of resized it, but we can probably have an inputs day 9.example -2, and if we scroll up to this, yeah, here is a larger example. I'll do that and go ULDRDLU and do that, and then do that, and then do that, and outputs.example. Yeah, I kind of don't need this on always on top anymore. This needs to be 36, I think, for the second part. So then outputs day 9.example -2, part 1, dunno, part 2, 36. And I guess like I'll just run our output. Alright, so it doesn't like something there. Right, length needs to be size. Right, that's all I need to change. Always good. Right, so our example just passes. That's actually pretty good. That kind of suggests that I've just passed completely. And we've got 88 for the second example, which I assume is the right answer for part 2 and part 1, but part 2 we don't know. And we also get a 2602 for the actual answer, which it was right. Cool, so I'm happy with that. So 88 I'll remember. So this can be 88 and output, we want that one, and if we run that again it passes everything. Cool, so what that was actually easier than I thought it would be. I'm happy with that. So we did like a bit of refactoring, so that move tail, yeah, it's kind of only moving the tail. I'm probably not going to change it, and then we kind of just made it a big size and only looked for the first and the ninth. I'm happy with that, and then we did that, and there should also be another example file. So if we add everything and do day 9 part 2 and do a pull rebase and a push. Might complain. No, we haven't restarted since. So yeah, that's that. I'm happy with that. We've solved both part 1 and part 2 of day 9, and we can return to our advent and do some cache busting. And if we do a test on everything, we should still kind of do it. And apparently an hour? Nah, 2 hours. Yeah, that kind of makes sense. But yeah, I probably won't be doing it then because got people around, so gotta socialise. But yeah, looking all good. Has to compile everything again. But yeah, this is looking good, and I kind of like this solution. We use like a few different things. I'm not sure why day 8 is open there. Yeah, we kind of use this structure with stuff inside of it that does stuff that kind of makes it a bit easier to and like this move point could probably be a function on point, but I kind of did it as a separate one, and this thing could probably maybe get changed with a match. I'll have to look up more how this matches work in jakt, but yeah, that's kind of doing that, and it never hit this abort, which means that the tail was always touching, assuming that our is touching function is right, which it just works out the difference, and as long as it's less than 1, it's fine, which I think that's probably pretty good. So I kind of like this solution. It's a bit longer than others, but it did the trick. This is taking just too long, but everything has worked so far, but yeah, no, I like this. Learning more about jakt as I go along. It's an interesting way to try and learn a language, but I'm enjoying it. It's kind of a different language, but also similar to ones I've used in the past. But yeah, it's good. And I mentioned in the last video that there are some other people doing advent code in jakt, so I might actually link it in that. Well, one failed, but it's with that stupid error code, which I should track down, but I think because I've done like 3 videos for this one day, I probably won't do that jakt in here. But this is looking like everything is working, and I think it's interesting because I'm only meant to recompile if I make a change to the thing. Right, we just got a kernel panic, but it looked like everything was passing, but that's alright. I think that's a good time to end the video because I can't be bothered restarting just to run the tests again. Everything looked like it's good. We've got all the stars, like look at all the stars, can't even move the mouse. So yeah, thanks for watching, and feel free to let me know if you enjoy this content. Feel